Tx will write it, Rx. Agree this will be, so now this will be the dt, distance covered by the transmitting antenna coverage, and this will be dr. Directly in this particular type of propagation, the transmitting antenna should able to see the receiving antenna. Able to see means you should draw a line. Don't again take like this. I'll stand here, sir. Then I'll ask my friend. Then we'll say, hello, how are you? No, not like that. You can't be visible. What is the distance? This can be up to say like a 40, 50, 60, or even 100 kilometers. It all depends on height of the antenna. So this is the height. This is the height of the receiving antenna. And this everything will become range. Range means don't take along the surface of the earth, you have to measure. Range or distance. So this coverage, what happened, it can go up to even few 100 kilometers. This one. So this called a line of sight. What do you mean line of sight? That if the transmitting antenna should be able to see the receiving antenna, means if you draw a line, it should be able to see each other. The meaning of that one. So look at this. So shall we call this is the origin? I know this surface of the earth. Here I'll start calling it as origin. We will put limit for this, the origin of the earth. How it is possible? The same diagram. Okay, if you look at the next set. Yeah, we'll go for here. Okay, let me bring another antenna. Okay, there's a transmitting antenna 1, TX1, this is TX2. Is there any communication between TX1 and RX? It's there. Is there communication between TX1 and TX2? There's no communication. So what is the range of this? The range of this will come only till here. I'll remove this. This may not be needed now. So what is the range of this? The range of this will come till here. Till P1, what happened? The signals will reach. I'll remove that origin word. Yeah. Now you see that one. Till where I'll receive the signal? Till P2. What about this? Till P1. Now, what about the station 2 and receiver? They are unable to communicate. Tell me, who is blocking this origin? Who is putting the limit? Who is putting the limit on the range? Shall I say origin? So how to increase the range? Shall I go for antenna? You look at the antenna, H1 and H2, HT1 and HT2 antenna. So the one which is having more height, what pen, it will have more range, no? So therefore, the limitation from where it is coming due to the origin. Due to the origin of the earth. Can we ask the earth to change its shape? Not possible. So no communication between TX2 and RX. Communication is there, communication occurs between. So shall we put like we will put the restriction on the range. So the range, shall I say, depends on the origin of the earth and also the height of the antenna. That's all. I'll just conclude this topic in this way. No communication between TX2 and RX, and communication occurs between this one. So therefore of all, so now, to have the communication between the station 1 and between station 2 and receiver, what we should do, I should increase the height of the antenna. So therefore, shall I say the range depends on height of antenna. So I need now expression for the height of the antenna. And now it can happen like this also. It can happen. There are two stations. Okay, we have designed it. So initially, no, like they struggled a lot. I'm telling this one. The Western science, they have struggled a lot to come till here. Now, what about these two stations? Are they communicating? So what is the maximum distance? It is still here, no? DT. And what about here? This is DR. So the what all signals transmitted by this transmitting station, are they able to reach the receiving? Nothing, finish all. No communication between TX and RX here for this diagram. So who is putting the limit? The origin of the earth. So therefore, shall I say that the shape of the earth is what is the biggest problem. So I do overcome this by proper designing of that. So I'm interested that range. I'm just bothered about the range. This particular the range of this depends on what, like something at DT and DS. So what is the total range? DT plus DR. That particular range depends on what is what I'll give the expression. Then I'll check that what range of signals I can use this for communication. What are the ranges? Okay, I think I'll have to communicate, no? So shall I say that what range of frequencies? Anything? Frequency should be less than 3 megahertz. Okay, we don't have exact boundary, say around 3 megahertz. So the ground wave propagation, what frequencies it will support? 3 megahertz, less than 3 megahertz. Anything more than that, the diffraction effects will come into picture and also attenuation. Diffraction effect and also there'll be more losses, higher frequency. So the ground wave supports the EM wave of frequency less than 3 megahertz. Okay, now let's come for line of sight. So definitely I'm interested, this range depends on what? Okay, let's take some geometry here. So this is the surface of the earth. Let's derive here. Antenna is needed, no? Yeah. Okay, there's an antenna. So it will radiate. So there's the center of the earth. We'll take O. Let this be E. This be P. Radius of the earth R. There's the height of the antenna. Height of the tower it is. The height of the antenna, everything. Okay, this one. This height of the tower. So high, greater the tower, more the range that one. So this distance, let it be equal to D. And even this distance also equal to, let it be D. It's not, I think it's a arc, this one. So we have a triangle here. So what is HT? Height of the tower it is. So don't get confused with other thing, that one. Okay, let's look at the mathematics. OA square, this will become right angle triangle. We'll derive that expression here. OA square, right angle triangle, what we have? AP square plus OP square. What is OA square? Radius of the earth plus height of the tower. And what is AP? D square. And what is OP? This is R square. So this I'll expand it. R square HT square 2R HT. R square gets eliminated. R square get eliminated. So the next expression what we get is HT square 2R HT equal to D square. Now what is what is HT will be very much less compared to R radius. So as HT will be very much less than. What is the height of the tower? 100 kilometer. Mobile tower, all of you able to see mobile tower? 100 kilometer, 10 kilometer, 1 kilometer, at the most maximum 100 meter. No? What is the radius of the earth? 6,400 kilometers. So height of the tower will be very much less than radius. So even HT square when it compared to 2R HT will be very small. So therefore the expression will become okay. Now you look at this one. The range, the distance up to which the signal can propagate will be 2R HT. So why I'm putting that distance up to which? Can this point, can it receive the waves emitted by this antenna? Not possible. No, the ground will not permit the waves to propagate, to pass through it. Please, all of you, don't draw a line, sir. Why can't? I don't know, like students nowadays. Sir, why can't the waves reach like this? Can they pass through? Can they penetrate through the earth? If they can penetrate through the earth, then no need of all this discussion. No? So at the most, this one, they cannot reach here. We are discussing line of sight of propagation. Directly the wave from point A should reach Q. Not possible. I think there's a 3D diagram, not a circle. This is the earth. Got the idea? Planet Earth, that one. So therefore now we have some sort of the thing. So shall we, in fact, how it will be? So some sort of circle, no, will come within that particular, like a circular boundary. If you are there, as you are going to receive signal emitted by that particular antenna. So I'll project this in the form of a plane diagram. If there's an antenna, no. If there's antenna, I'll draw a circle. So there's the height of the antenna. Then this will be the distance D. And what is the D? D is equal to what? 2RHT. The height of the tower will determine to what extent the signal will receive. Suppose if you are standing here, so which person will receive signals? This is like a mobile tower. You don't receive, so the person 1, 2, and 3. Person 1 and 2 will receive signal emitted by
1 and 3, sir.
1 and okay, I'll do one thing. 2, I'll write it. Person 1 and 2 will receive signal emitted by tower. This is emitted by tower. Is what antenna will be? The antenna will be very small. I think am I right? What about 3? Person 3 will not receive signal emitted by tower. Any reason for that? Is out of that particular range. So like this, what happen? What the range up to which the signals can be received? It depends upon this particular diagram. So suppose say if you have this one, usually what is the height of tower? Will be some 40, 50 meter. What is the height of antenna? Will be very small, 1 meter, 2 meter, like that. I don't know, some books they're given question like this. Huh? This antenna. this antenna, and is telling what be the range of this one. Is telling height of the tower, this one, and height of the antenna. So let me write H1, H2. Again, the formula will get disturbed. So this part is antenna. This is a tower. So then what is the expression? The expression will become D is equal to, how much it is? 2R H1 plus H2. Usually what is height of tower? Will be 50, 60 meter, and height of antenna will be 1 or 2 meter. We can't construct such a antenna of that one. Will be very costly. Antenna should be designed properly, shape everything, that one. So I don't know, the question came like this. 20 meter antenna and 30 meter tower. Okay. On paper, okay, but practically if you go and know, we'll never get anywhere in the world of that kind. So I don't want to give wrong information, but since it's coming in weekend exams here and there, no, so just to improve your marks I'm giving. Actually I should not teach like this. I should not be there. Nowhere in the books world, if you look at any electronic communication books, no, height of antenna should not come into picture. Finish. Nobody will construct such a huge antenna. The height of the tower matters here. This one, the 3 will, so any person who is receiving within this, like a circle of radius D, they're going to receive the signal. So this is a reception area. This is a non-reception area. Non-reception, we don't receive signals. Like that. Surrounding this. So you have to be in that circle. That's what it's telling. So like that, I think now we know surface of the earth. We know surface of the earth, and I'll give the some towers. So like that happened by going for different, like a transmit, like a towers of certain height. No, we can cover the entire surface of the earth. I think that's what we are doing in mobile communication. In mobile communication, what we do, I'll map the Hyderabad. Then, so I know the height of the antenna what I'm using. So I'll calculate the D. So total Hyderabad area is, say, let's say like around 400 square kilometer. I think 500 square kilometer, and each antenna will cover so how much? 50 kilometer. So the surface area, so 50 square kilometer. Then how many antennas needed? How many mobile towers? 10 mobile towers are needed. Suppose the total Hyderabad is having 500 square kilometer. It will not be exact perfect circle. So this is 500 square kilometer. Each antenna, if it provides 50 square kilometer, I think 10 antennas are sufficient, no, to provide. Like this, you can see the towers at several places. I think, okay, one more antenna. Like this, 10 antennas will do sufficient coverage. Suppose say you are here, where signal weak, signal weak, signal weak. Maybe you are away from antenna. You are away from antenna. The method of, even where do we use this communication? In the mobiles, television, even in FM, we use this one only. What is the range? What is the frequency range? Okay, let's go for frequency range. Directly what happened from the transmitting and receiving station. Receiving station, who is receiving station? The person's mobile only. That's why I do person. I didn't draw the receiving station. So initially I just shown it. So here, come back here. What should be the distance S? Should be equal to 2 times of 2R HT plus 2R HH, no? The total distance between transmitting and receiving station should be, what happened? It depends upon the height of the transmitting as well as receiving tower. When you are communicating between the 2 stations, but basically this is used for communication like this. So what is the height of the person compared to radius, or negligible? Then definitely the D depends only on HT. So you can ask questions, person 1 is the receiver. Why the height of the person will not come? Height of the person compared to radius of Earth, negligible, no? So is it justified writing D only 2R HT? What is the frequency range? Anything greater than 40 megahertz. We will just summarize. Frequency, anything greater than 40 megahertz. All use applications. Applications, FM band, mobiles. I'll just write only mobile. Mobile communication it is. Okay, I'll put it. Television, TV transmission. Okay, all this what we use. This particular thing, that one. So now the maximum range depends on what? Range, shall I say, depends on tower and origin of Earth. The shape of the Earth is what matters here, no? Okay, now one more thing, that one. If we have population density, number of receivers, suppose like I'll go for population density. We'll introduce here only this idea. Population density, I'll write ND. Nothing but mobile users, number of mobile users. Then like a population density, number of users per unit area, it is. How you define that one? So number of receivers means number of receivers, N it is. So this should be equal to pi d square into ND. Number of like a mobiles per unit area, that's called like a population density. So number of receivers is equal to area into population density will give the number of users. That one. So usually what happens if you see before launching any telecommunication mobiles, that one, what they do, they come and do survey in that area, how many mobile users are there. Okay, calculate. Then they'll go for population density. They know number of users and the population. From that, what they'll estimate what should be the range. Once you know D, then what you can do, you can go for the height of the antenna. So what is the height of the antenna now? Or height of the tower. So what is the height of the tower equal to? D square by 2R. So like this, based on the population density, what will happen? It has to be researched. So now bring that D square, eliminate D square. We'll get expression for D square is what? We can write it as N pi population density. I think I'll write, let it be this simple. 2 pi R. So what should be the height of the tower needed? Given by this particular thing. D square I'll replace like height of the tower. In place of D square, I'll write it like N pi by ND, that one. So what should be the height of the tower? The number of receivers, population density, and this particular. Like this, we'll use this particular formula. Or else I think, okay, this is not needed. It will give other way. So what should be the height of the tower needed? It all depends upon these conditions. Okay, fine, that one. So we'll calculate population density is very important. Population density means not human population, the receivers. That's why I wrote it here. Number of receivers equal to number into pi d square. So population means here mobiles are better. Because this you will understand very easily. That's why I wrote mobiles. Okay, this is about the, it's also called as, you see the name, space wave. Don't think that space wave means something like a outside atmosphere. This will be very confusion for students, space wave. Okay, the last one, the sky wave propagation. I will take help of the ionosphere layer of the Earth for the communication to take place here. Okay, this is the ground or the surface of the earth.